Hey pre-calc, this is the second half of 7.5, and what we're going to be doing is graphing this. Now this problem is pretty straightforward, not a whole lot going on, but I do want you to get the practice out of this, that we have two shifts going on, that we have a shift left 2 and down 5. So before doing anything, you might even recognize that the horizontal asymptote is at y equals -5. So that might even be the first thing that you do. Okay. Another thing that you might even recognize is that, okay, well, if normally the the y-intercept is at 0, 1, and if I shift that left 2 down 5, we're right here. Okay, and again, I've actually seen, and maybe I'll even teach this one this way, where I've seen students draw out the parent function. So I'm doing this in a very faint color, just to try and show you that you can pick out those main points. So I'll call this f of x, because that's what we named in the first video, 2 to the x power. So what we're doing is just taking each one of these points and shifting left 2 down 5. This is another point. It's normally at 2, 4, left 2, 1, 2, 3, 4, down 5. And so without showing the table like I showed you in the first video, you can come up with a pretty good answer for the graph of k of x. And you can see that, based off of everything that we've done, it's pretty close. So otherwise, what I would like to see is the rule. I kind of did this not the way I wanted to do it, so let me fix that. Erase right here. There we go. That I want to see the rule written out like this. Left 2 means x minus 2, and down 5 means y minus 5. So when we compare some of the points, I don't need to see more than 3 points. I think 3 is good enough. That when you point out that, okay, well, normally it's 0, 1, 1, 2, and 2, 4, and we follow these transformations. Well, if I plug in 0 for this x, 0 minus 2 is -2, and plug in 1 for this y, 1 minus 5 is -4. Well, if you look at that ordered pair, -2, -4 was exactly what I did. That's a point that's on my curve. So same thing, plugging in 1 for x, 1 minus 2 is -1. Plug in 2 for y, 2 minus 5 is -3. Look at that. -1, -3 was a point on my curve. And then you can do the same thing with this last point to see that 0, -1. And again, I think 3 points is enough because you should know the nature of an exponential function, whether it's growth or decay. So as I move on to the last page of my notes, we have 2 where we change the base around. So I'm not upset if any of you just in a faint color, maybe you draw in what the parent function of this looks like. Okay, this is an option for you to draw, and I'm going to rename f of x to be 1/2 to that x power. But again, notice I'm using a faint color to try and help me out, because as I'm looking at my transformations, the first thing is we have a x-axis. I almost wrote down y. Reflection, that's from this negative. There's no y-axis reflection because there's no negative with this x. So therefore we can deduce that minus inside the parentheses is shifting right 2. Forgot to finish writing reflection apparently. And that plus on the outside is telling me to shift up 2. And that's also your clue that you have a horizontal asymptote at y equals 2. And maybe that's the first thing you do, is you put in a horizontal asymptote at y equals 2. But the other piece that I'd like to see is that you actually write in that xy is following these patterns. So shifting right 2 means it's x plus 2. The x-axis reflection means we have to negate y, and shifting up 2 means adding 2 to that. Now notice as I make my table of values, and again I'm naming these f and g, I want the better ordered pairs. What am I talking about? Is I'd rather see 0, 1 because it's an integer with the next integer of -1, 2 on the parent function for 1/2. So notice we're dealing with the exponential decay function here. So that's why I'm changing over to the negatives. But again, I'm using 4 of those ordered pairs. So as I look at my shifts, plugging 0 in for x, well 0 plus 2 is +2. Negating y, so negating the 1 is -1 plus 2 would give me 1. So the ordered pair for this function should be right 2 up 1. So doing the same thing for x is -1. -1 plus 2 is 1. Plugging in 2, well, negating 2 for y is -2 plus 2 is 0. So 1, 0 should be a point. And then -2 in for x plus 2 is 0. The negation of y, so -4 plus 2 would be -2. And I should have color-coded, but you can forgive me, that our exponential problem is now a growth problem because we had a base that was smaller than 1 with 1 reflection, so it should be exponential growth. So make sure that you give me some sort of indication on where the horizontal asymptote is. And I don't mind seeing the parent function. Just make sure that it's clear that my blue curve is your final answer. Okay. And by the way, you're not getting points taken off for artistic ability. Try your best on making this look like exponential growth. Things like that. Because if we look at this next one, and again, if it's helpful, again, you don't have to. Just draw in what the normal function for exponential decay looks like. And this should not look like it's going back up, so I'll delete that little piece right there. Okay. So if that helps you identify that, okay, we have I did it again. That negative is an x-axis reflection. I'll just stop right there. And let me color code that this negative is a y-axis reflection. But I like to label those first. And if it's helpful, remember we talked about setting the argument, which is -x plus 3, equal to 0. So I'm adding x to the right side. This is helping me see that this is shifted right 3. And I don't know, I'm kind of running out of colors. But we have that -1 right there. That's a shifting down 1. So that's my clue that we have a horizontal asymptote at y equals -1. And that might be the first thing that you even do. That you just draw that in. And we've talked about other things as well, like having a negative in front is telling us that we need to be below the horizontal asymptote. But again, I'd like to see you practice that skill of writing x comma y and then changing it the way we need to. Well, if we have a y-axis reflection, that's a negative to the x, and we're shifting right 3. But remember, we talked about this earlier in the year. If you have a y-axis reflection, you just rewrite the argument, so it's -x plus 3. And then we have -y, because it's the x-axis reflection, -1, shifting down 1. So as I pick out 3 key points, and I'm going to go back to calling it f of x. And this function is called g of x again. Not really a big deal, but I like using these ordered pairs for this decay function. And you can choose different ordered pairs. I'm not offended. If you like fractions, go for it. So if we plug 0 for x plus 3, we get 3. Plug in 1 for y, -1 minus 1 is -2. Plug in -1 for x, so negating that becomes +1. Plus 3 is 4. And -2 minus 1 would be -3. And -2 in for x, so +2 plus 3 is 5. Plug in 4. -4 minus 1 is -5. So as I plot those 3 points, We have 3, negative 2, 4, negative 3, 5, negative 5. Oops. It's only the second mistake I've made, so that's not too bad. Maybe it's a third. I don't remember. I wanted the bold color. So then our final answer is this, and we've talked about it. We have a exponential decay, and we can confirm it because our base was smaller than 1 with 2 reflections. Yeah, so we know that this is correct. We've done all this. Now, can you check your work with a graphing calculator? Yes. You just never know on a test. You know, if we have an in-person test, you might not have a calculator to do this with. So you should be ready for your homework now. Perfect. We'll see you.